Dear students, we know also we discuss what is the limit points of a set. Also know the derived set of a set A. That means A is a set. The set of all limit points of A is called the derived set of A. This is denoted by dA. Now we prove that a theorem, the most important theorem, which states that let X be a metric space and A subset of X, then A is closed in X if and only if it contains all its limit points. That means A is closed in X if and only if dA is a subset of A, where dA stands for the set of all limit points of A. Let A is closed in X. A is closed in X and X is a metric space. We have to show that dA is a subset of A. In order to prove dA is a subset of A, it is sufficient to show that every element of dA is an element of A. So we take a point in dA, let X belongs to dA, which implies X is a limit point of A. Since X is a limit point of A by definition of limit points, every open sphere centered at X with radius R such that SRX minus X intersection A is not equal to phi for every R is greater than 0. That means for every open sphere centered at A and radius R which contains no point of A except X. Now we claim that X belongs to A. If possible, let us suppose that X does not belong to A. Since X does not belong to A, X belongs to its complement. X belongs to X minus A, that is equal to A dash. It is given that X minus A is open because A is closed implies X minus A is open. Since X minus A is open and X is an interior point of X minus A, then X must be an interior point of X minus A, which implies there exists a open sphere of X with radius R such that SRX subset X minus A for some R greater than 0, which implies SRX intersection a complement of complement equal to phi, which implies SRX intersection A is equal to phi, which implies X is not the limit point of A. But this is a contradiction. This contradiction occurs, our assumption is wrong. What is our assumption? Our assumption is X does not belong to A. Hence X belongs to A. Before we take an element in dA, X belongs to dA implies X belongs to A, which implies dA is a subset of A. That means A contains all its limit points. Let us conversely suppose that dA is a subset of A. That means A contains all its limit points. We have to show that A is closed. Let dA subset of A. To show that A is closed in X. In order to prove A is closed, it is sufficient to show that X minus A is open. Let X belongs to X minus A, which implies X does not belong to A, which implies X does not belong to also dA. Why? Because A is a subset, dA is a subset of A. So there must exist R greater than 0 such that SRX subset X minus A, which implies X is an interior point of X minus A. Since X is an arbitrary point of X minus A, then every point of X minus A is an interior point. By definition of open set, X minus A is open in X, which implies A is closed in X. That means if A is closed, if and only if dA subset A, that means A contains all its limit points.